Okay, section 2.2. Today we're going to focus on addition. So all of the problems we'll be doing today, just remember, are addition. We'll get into subtraction, multiplication, and division later on. It's a lot of rules to remember at one time, so we're going to kind of break them apart, and today solely focus on addition of real numbers. Okay, so the way I see it, there are only two types of addition problems. Okay. The first type we are going to call war, and I will expect everyone in the class to know what a war problem is whenever I mention war problems. And we were all taught how to add and subtract integers back in middle school. I'm not asking you to do anything different. It's really just some nomenclature that I want you to recognize and be able to use yourself. So what do I mean when I say war problem? Well, around the time I was your age, this is just the way I thought of adding integers, basically. I imagined conventional warfare, not the way people fight wars today, but like back in the Civil War, the Revolutionary War. They kind of fought differently, and if you think about what I'm talking about, sometimes we imagine the soldiers kind of marching in lines, maybe meeting the enemy on a battlefield. Everyone's kind of lined up and there's this sort of ready, aim, fire, and you have both sides firing at each other simultaneously. And that's what we're going to replicate when we talk about the war problem. Okay, so I want you to imagine that there is an army. Maybe on one side we have the positive army, and on the other side we have the negative army. Okay, and we're going to imagine some soldiers meeting on the battlefield. And so let's say for the positive army, this is what I'm going to use to draw soldiers, and I'm going to draw them in lines. This is actually the Chinese character for man. And you can see it's kind of like a headless stick figure. Those are the little legs there. So we have a front row here of 8 soldiers, and maybe some guys on the back row. So just kind of bear with me here on my explanation. So that's going to be our positive army. And then the negatives, these guys, we're going to give quite a few more soldiers too. So you can see these guys are packing a little bit more of a punch. Okay, so imagine that these two armies meet on the battlefield, and we're also going to make the assumption that they all fire simultaneously and they're all perfect marksmen. So they're kind of going to shoot at each other. For example, this guy in the front row over here might shoot toward this guy and vice versa at the same time, and the result is that both are going to be annihilated or eliminated. This guy over here is going to take out this guy over here, and vice versa. Matter of fact, the whole front row would take out the whole front row of the other side. And then these 5 guys on the back row of the positive army, they're going to be taken out by these 5 guys, 1, 2, 3, 4, 5 of the negative army. And so that's sort of what happens in the war problem. Well, what we just accomplished, what we just did, is we basically modeled an addition problem. So let's maybe go back to the beginning here. What we had originally were 13 positives. And we're doing addition. And then on the negative side, if you count them up, I believe we have 28. So negative 28. In the war type situation, you have positives and negatives going up against each other. And one of the sides is going to try to win the war. Now notice I have 2 signs grammatically speaking, they're not allowed to touch. So when I put parentheses in here, we're not thinking like PEMDAS order of operations. This is just mathematical syntax. You can't have two signs touching. So I'm protecting that negative 28 just to kind of show that I'm adding a negative 28. All right, well, let's go back to the war really quickly again. We saw that both front rows annihilated each other. And then 5 guys in the second row were taken out. And then we were left with this many. So when you have a war problem, you basically ask yourself 2 questions. Okay, 1, who won the war? Positives or negatives? And we can see here that by far the negatives definitely won the war. And then how many did they win by? How many guys are left over? And if you count that up, you're going to see that there are 15 of those negative soldiers remaining. So who wins the war? In this case, the negatives. How many do they win by? 15. That's why our answer here is a negative 15. So in a war problem, you'll see positives and negatives opposing each other. Okay, make sure you have out that pencil and paper. And let's go ahead and do some practice. I want you to do these on your own, and then we will go over answers together. Go ahead and hit pause now. Do these on your own. Okay, let's see what we came up with. These are all war problems. In number 1, we have negative 38 plus positive 56. It looks like the positives are going to win there, and the positives will win by 18. In number 2, we have negative 16 plus 7. The negatives are going to win there, and they are going to win by 9. Notice we're never going to draw out those crazy diagrams. That was just for illustration purposes. You can do these in your head, or if you're not sure how much one side wins by, then you just need to take the absolute value of each number and subtract them. You're looking for the difference in the 2 numbers. All right, 17 plus negative 23. The negatives are going to win there, and it looks like they win by 6. And then on number 4, we don't have integers here. We have some decimal numbers. These are part of the rational number family. 8 plus 6 plus negative 2.9. And you might kind of pause there. It looks like the positives win. How much do they win by? Well, you might not be sure. So this might require you to do a little bit of side work. Like I said, we're going to take the absolute value of both numbers. So imagine just an 8.6 and a regular old 2.9. And we're going to find the difference of those. Okay? I can't take away 9 from 6, so here we're borrowing. And this ends up being 7. It's a decimal. So it looks like 5.7. And then go back to the signs. Who won the war? Well, in this case, the positives won the war, so it's going to be a positive 5.7. We have 5.7 left over. Okay, very good. Hopefully you got all of those correct, and if not, then we will do some more practice tomorrow. You can go back and revisit that. Let's move on to the second type of addition problem. Not all addition problems have a positive and a negative going up against each other in a war-type scenario. So what we will call the getting mugged twice problem. Getting mugged twice in one day, or just get mugged twice. This is sort of a different scenario. And this is also how I thought about it when I was your age. Okay, so just kind of imagine this story here. You decide to walk to the local Circle K to pick up some snacks. And when you leave your house, you have $17 in your pocket. Unfortunately, you get mugged. So you go home, maybe you cry a little bit, but eventually you muster up the courage to try again, and you scrounge up about $6 in change. Around your house, you set out to do what you could not do before, but alas, you get mugged again. Okay, so this is the story I want you to kind of remember when you see this scenario. Let's take a look at that original $17. Okay, that $17, when you had it, would be considered positive. But the minute you got mugged, it became money that you did not have, and so it became a negative 17. Okay, we're doing all addition problems today. That $6 was also positive, but the minute you got mugged the second time, it became a negative $6. So here you notice that both numbers in play happen to be negatives. All right, and please don't get confused. When we add two negative numbers, you're going to get a negative number of more magnitude. For example, you lost $17, you lost $6. When you combine those losses, okay, all together you have lost $23. Every once in a while we might get confused and say, well, wait, I thought a negative and a negative made a positive. Those are multiplication rules. That'll come later. Here we're adding up our losses. Okay, so getting mugged twice. You lose 17, you lose 6, you've lost 23. Sometimes I'll also refer to this problem as the gambling addiction problem because you keep going farther and farther into the hole. All right, so let's do some practice with get mugged twice. Okay, so go ahead and get your pencil and paper, blue examples. All of these are get mugged twice problems. I want you to try them on your own first, so go ahead and you'll hit pause and then we can reconvene to go over answers. Notice that all of the second numbers have parentheses around them, and that's just mathematical grammar. If I were to take away those parentheses, I'd have a plus sign and a negative sign touching, and you're just not allowed to have two signs touching. It's just syntax. Okay, let's see what you came up with. All of these are get mugged twice problems. Let's take a look at number 1, negative 20 plus negative 32. You lose 20, you lose 32. We're talking about a total loss of 52. On number 2, you lose 17, you lose 19. All together, add them up. You have lost 36. Number 3, you lose 1, you lose 2. All together, you've lost 3. And then number 4, I've given you some decimal ones again. So you've lost $12.40, let's say, and you've lost $9.70, let's say. How much have you lost altogether? Well, in this case, it would make sense to add those numbers up. So we might have to do a little bit of side work again, just to make sure. There's no shame in that game. And of course, you can use your calculator, but I think being able to do this stuff out by hand is really, really important. And some tests that you take from me, you won't be allowed to use your calculator. Sometimes you will, sometimes you won't. So you want to make sure that all of your skills are rock solid here. All right, so it looks like we come up with, nope, carry the one. 22.1. And then we have to go back to our, to our story again. If we've lost 12.4 and we've lost 9.7, our answer is going to be negative because it's money that we have lost. And we're talking about a negative 22.1. Okay, so now you have to be able to distinguish between the get mugged twice situation and the war situation. And that will be my hope when you work on the assignment tomorrow. So let's move on to the next set of examples. Oops, sorry. Okay, so I want you to do two things for example 3. The first thing I want you to do is just identify what type of problem we are talking about. That's probably the most important thing here. The math itself is not that hard. The identification is important. So let's do number 1 together. Okay, when you look at number 1, do you see a war problem or a get mugged twice problem? Okay, I've got one positive, one negative. That is definitely the war situation. So I do want you to classify these. Okay, it's a war. Now who wins? Go ahead and answer it yourself. Okay, the positives win. They win by 1. Okay, so it'd be a war problem with a positive 1 answer. Go ahead and take a look down. Look down at 1, 2, 3, 4, and 5. Which problem is the first get mugged twice problem that you see? Okay, it's not number 2, but if you look at number 3, we do see a get mugged twice. So maybe you can just abbreviate that as GMT for our purposes here. That's a get mugged twice. You lose 9, you lose 4. Altogether, how many have you lost? You've lost 13, so negative 13 answer. Okay, I want you to do the rest on your own. So go ahead and pause now, and then we'll reconvene and go over answers. Okay, let's take a look at number 2. We've already done numbers 1 and 3. For number 2, that is a definite war problem. And the negatives win. They win by 4. Okay, number 4, hopefully you had it down as a war problem. Positives win, and they win by 5. Okay, number 5, also a war problem. Negatives win, and they win by 3. All right, now number 6 is a get mugged twice. You lose 14, you've lost 21 altogether. You've lost 35. Number 7 is a war problem. Looks like positives are going to win, and they win by 24. Number 8 is a war problem. Negatives win, and they win by 8. Number 9 is also a war problem. Positives win. They win by 24. And then number 10 is a get mugged twice. You lose 5, you lose 2, you have lost 7. Okay, so hopefully you got all of those correct and you are ready for tomorrow. All right, good job.